Okay, in this video I will go through question 9 and 10. Question 9. G of x is given as a 4x cubed minus 12x squared minus 15x plus 50. So, question 9. Gx is equal to 4x cubed minus 12x squared minus 15x add 20. Part A. Use the factor theorem to show that x plus 2 is a factor of g of x. To show that x plus 2 is a factor of g of x, we need to show that g of minus 2 is equal to 0. If x plus 2 is a factor of g of x, then g of minus 2 must be equal to 0. Substituting minus 2 into g of x, we get g of minus 2 is equal to 4 times minus 2 to the power of 3 minus 12 times minus 2 squared minus 15 times minus 2 plus 20, which we get minus 2 to the 3 is minus 8 minus 32 minus 4 times 12 is 48 plus 30 add 20, which is equal to 0. Therefore, g of minus 2 equal to 0, which implies that x plus 2 is a factor of g of x. Part 2, or part B. Hence show that g of x can be written in the form of x plus 2 times by ax plus b squared. To show that g of x could be written as x plus 2 times ax plus b squared, all we need to do, just use the long division to find the other factor or factors of g of x. Okay, so 4x cubed minus 12x squared minus 15x plus 50 divided by x plus 2. So how many x goes into 4x cubed, which is 4x squared? 4x squared times x is 4x cubed. 4x squared times by 2 is 8x squared. Take away this one from the top, we get minus 20x squared minus 15x add 50. Now how many x goes into minus 20x, which is 20x squared minus 20x. Minus 20x times x is minus 20x squared minus 40x. So minus 20x squared plus 20x squared is 0. Minus 15x plus 40x is 25x plus 50. How many x goes into 25x, which is 25. 25 times x is 25x. 25 times 2 is 50, which is 0. So therefore, g of x could be written in the form of x plus 2 times 4x squared minus 20x plus 25. and g of x is equal to x plus 2. Let's factorize from 4x squared minus 20x plus 25. One of the easiest methods is just to use the calculator and find the roots of the equation. So whatever root you get, you can work backward to find the factor. So it is a polynomial number 2, the degree of polynomial is 2. So 4x squared minus 20x plus 25. So we get x equals to 5 over 2. It doesn't say x1 and x2, so only x equals to 5 over 2, which means there is only one single root for this, or repeated root rather. So if x is equals to 5 over 2, 2x minus 5 is another. 2x minus 5, 2x minus 5. Therefore, g of x is equals to x plus 2 times by 2x minus 5 squared. Therefore, a is equals to 2 and b equals to minus 5. Okay, let's move on to the part C. Here is a graph of g of x. Okay, figure 2 shows a sketch of part of the curve with the equation of y equal to g of x. Use your answer to part B and the sketch to deduce the values of x for which g of x is less than or equal to 0. G of x is less than or equal to 0. So we can clearly see here is where g of x is less than or equal to 0. Obviously the point when the graph is cutting the x-axis is part of the solution, and also g of x is equal to 0. The y value here is equal to 0. So there are one repeated root, which is 5 over 2 here, and one root here minus 2. So therefore, for part C1, g of x less than or equal to 0, as shown on the graph, x must be less than or equal to minus 2, and x must be equal to 5 over 2. Less than or equal to minus 2, and x equals to 5 over 2. Okay. Then the last part of the question 9, part C2. It says g of 2 of x is equal to 0. So for g of 2 of x equal to 0, first of all, what impact this 2x would have on the graph? So it will stretch the graph on x-axis by a scale factor of half. Therefore, the roots will become half as well. So x equals to minus 2 will become x equals to minus 1, and x equals to 5 over 2 will become x equals to 5 over 2 over 2, which is 5 over 4, or 1.25. Okay. So now let's move on to question 10. Okay. So question 10, prove from the first principle that the derivative of x cubed is equal to 3x squared. Okay, let's use the new page. Question 10. Prove that derivative of if f of x equal to x to the power of 3, then f prime of x equals to 3x squared. Okay, so we want to prove this. First of all, we know the formula for the first principle. F prime of x is equal to limit of f of x plus h minus f of x over h when h is tending toward 0. So let's work out f of x plus h separately. F of x plus h, f of x is equals to x to the 3, therefore f of x plus h is equals to x plus h to the power of 3. There are two methods or three methods rather, to work out this, to expand x plus h. One is using the binomial expansion, and another is basic algebra, just writing x plus h 3 times and multiply by expanded, or write down x plus h squared times x plus h. So I use the last one. F of x plus h is equals to x plus h squared times by x plus h. So x plus h squared is x squared plus 2xh plus h squared times by x plus h. X squared times x is x cubed plus x squared h plus 2x squared h plus 2xh squared plus xh squared plus h cubed. It simplifies to x cubed plus x squared h plus 2x squared h is 3x squared h. 2xh squared xh squared, which is 3x h squared plus h cubed. So therefore, f prime of x is equal to limit of x to the 3 plus 3x squared h plus 3x h squared plus h cubed minus f of x, which is x cubed, over h when h is tending toward 0. Okay, so let's simplify this a bit further. F prime of x is equal to limit of x to the 3 minus x to the 3 is 0. So what is left over is 3x squared h plus 3x h squared plus h cubed over h. Now we can factorize from h. So we get limit of 3x squared plus 3xh plus h squared over h when h is tending toward 0. This h and h cancels. F prime of x is equals to limit of 3x squared plus 3xh plus h squared when h is tending toward 0. When h is tending toward 0, 3xh become approximately equal to 0 because h is very small number, very close to 0, and h squared becomes 0 as well. So therefore, f prime of x is equal to 3x squared. And the end of the question 10. In next video, we will go through the question 11 and 12.